Hello, everyone, and welcome to this talk on the Sec4Dev conference. My name is Julien Veillon. I'm a security engineer. I work at Google. I previously worked at Mozilla and a number of other places, and I'm the author of a book called Securing DevOps. And today I want to talk about the rapid risk assessment framework that we developed back at Mozilla with a colleague of mine named Guillaume Destender. And we spent many, many years using there to assess risks and model threats in the Mozilla ecosystem. And now we are expanding essentially the use of the rapid risk assessment to other organizations and sharing it with as many people and companies as we can. So rapid risk assessment came about as a way to provide security design reviews to engineering teams at a low cost, trying to move away from the very heavyweight and expensive techniques that existed to do really complex risk assessments and really have an approach that was a lot more agile, really, and interactive with engineering teams. And instead of really spending a lot of time going through the details of RRA and the various and how it compares to various methodologies, I thought it would be more interesting for everyone to just walk through an example. So throughout this talk, I will be essentially taking an example project from the perspective of developers and running a rapid risk assessment through it. And I'll explain how to approach the different sections of the RRA process and how it essentially can be perceived from the perspective of engineers and what security engineers need to focus on when running those exercises. So without further ado, here we go. Sam and Mark are two engineers that are building a file sharing application. They want everyone to be able to share stuff, whether it's files, photos, videos, anything, as easily and securely as possible. So they have a few IDs on a wireframe and a very early web app prototype, something that's incredibly lightweight and early stage at this point. And down the road, they kind of envision developing maybe an Android app, an iPhone app as well, and why not trying to monetize it as well for people who share heavily, maybe with higher quotas or some limits or some more telemetry data, statistics, etc. But they're very concerned right now about the security of their project because the main selling point is to provide a secure way of sharing files. And so they're trying to think about ways to make their app and their project as secure as possible. Now, Sam and Mark work for a software company, a pretty successful one with a few thousand engineers and a few successful products. And lately, they felt like internal processes were becoming more and more painful, were taking more and more of their time. They've heard that reviews, whether they were for legal or privacy reasons or security reasons or operational readiness reasons, etc., could take a lot longer, sometimes weeks, that get added to projects. So they're very worried about the cost of all of that red tape, and they really want to be able to run a prototype and an experiment with as little friction as possible. So they know they need the help and they want to ask for a security review, but they're also very concerned about it not being too heavy of a process. So they place their request and they meet Jim. Jim is a security engineer. Jim is sitting at his desk there, mumbling something about PGP and why are people still using it? It's 2021. Why don't they just use age? It's written in unsafe languages, memory safety issues all over the place. What is this thing? So Jim's tired a little bit. Jim could really use a vacation, and Jim has had a tough year, and it would be nice if he could take a break. But anyways, Jim is friendly enough, and he tells them, yes, absolutely, I can run a security design review with you. And he tells them that he will schedule a 1 hour meeting to go over their project and review the various aspects, and he will use something called a rapid risk assessment, or RRA. It's not R like parrots, R, right? The RRA, right? It's not necessarily easy to say, but that's the acronym RRA. And Sam and Mark, they don't really know what to expect. So they're like, okay, do we need to prepare for anything? And Jim tells them, well, don't worry too much. It's going to be a friendly conversation. Just send me in advance, like any architecture document you may have, product design doc, etc., etc. And if there are folks that you think need to be part of the meeting, then invite them and have them join. So they do that, and a week later, they all meet remotely, right, on video conferencing, and they do a little bit of meet and greet. And Jim tells them right away, well, we're gonna start by doing a little bit of information gathering, because Jim doesn't know anything about this project. He's barely looked at it. Maybe he's opened the documents once and just read the outlines, but he doesn't really have any useful details yet. So he asked really context-oriented questions. Who within the company is going to own this service? Who are the developers? And who is going to operate the service itself? And is it going to be done entirely internally? Are we going to outsource part of it? Are there partners involved, vendors, etc., etc.? And then who is the audience? Who is going to be using this thing? Is it internal? Is it for our own needs? Is it for the public to use? Is it for a specific population of users? Is it part of a bigger suite of products or something standalone, etc.? Just trying to understand the business opportunity here, the value proposition, all of that, get a good framing of what is being designed. And then the user stories are extremely important to Jim, really trying to understand how users are going to use this thing. So here, Sam explains we have user Moana, and she really wants to build a boat. So she wants to share a large PDF with a plan to build a boat with her dad. But her dad is not very good with computers, so she knows she can't, maybe even sending him an email may be too much. So she really wants to upload the large PDF on a sharing service and just send a link to her dad, maybe via text or something like that. Then he can just click on it and open the document. Now, obviously, it's a secret project, so she doesn't want anyone else to see the plan for the boat. So she wants to protect that document with a password, right? That's an example of user stories. Okay, gives Jim a pretty good understanding of what we're going for here. And then obviously how it is being built is very interesting as well. So for this particular one, there is a very basic architecture diagram, and it shows a Python application, maybe using Flask, hosted in a container, perhaps running in Kubernetes in production, but for now it's just being deployed in Heroku. The uploaded files get stored as objects in S3. And there's a Postgres database that stores a bunch of metadata for the application to run. Oh yes, and the front end, the web front end is in React, but it's all API driven, so that if there's an Android app or an iPhone app down the road, it would just talk directly to the Python backend. So pretty standard stuff from a cloud service perspective, and it all fits within existing technology stacks that the company uses. So Jim has a pretty good understanding of the baseline, right, of this kind of service. Now, this first phase, what's important in information gathering phase, is really to gain a high level understanding. We don't really care too much about the details at this point, right? So for example, the Python application, well, are we going to use SQL Alchemy or something else, etc.? That's not particularly relevant at this stage, right? We're really more concerned about understanding at a high level what this project and this product is about, and we can revisit the implementation details later on. What's very interesting to discuss is the investment level, right? So if a team is building a prototype or an experiment that's meant to be as lean as possible, then security investment will be minimal, right? And we're really trying to stay at a low risk level without really spending a whole lot of time on hardening. But if we're building the next major product of the company, then there's going to be a major investment, and security will also be a major investment. And there are more chances then we can push for more security work in that major product. So understanding really the investment level is important. From really a security engineer perspective here, what's important is to create a connection with the team, right? Ask relevant questions, take very, very good notes, as detailed as possible, capture all the links to the documents and revisit them later. And also listen as much as possible to what the engineers, the product managers, the folks coming with the design are talking about, right? And that all participate to creating a pleasant conversation, really a safe environment where we're not being judgmental. We're just trying to understand what is being built here. So with that context set, the next step is to look at what information and pieces of data the project is going to be manipulating. So for that, the phase 2 is to build a data dictionary. So the questions here are pretty basic. A good way to start this is, well, do you have a database schema, and what is kind of product related in that database schema? Now, we don't want to capture the exact database schema here. We want to capture the high level set of data pieces, right? So for example, here we know that the database will need to know about the user account, right? Maybe there is an anonymous mode, but maybe there is a logged in mode, and for the logged in mode, we'll have an identity attached to it. We store that in the database. The user data itself will be the blob that gets uploaded by a user to be sent to one or multiple recipients, right? And that's probably going to be stored in a bucket or in a storage somewhere. We'll probably have a data ID attached to that blob that's probably going to go in the database as well, right? If there is a password, then indeed there's a password. Is that going to be touched by and handled by the service? Probably not, but it's interesting to know that that's one of the pieces of information that users will have to deal with, right? So we don't only care about stuff we have to store here, but really we care about the data model of the application itself. And finally, we probably will have some telemetry around the data, right? How many times it's been downloaded, and statistics around it. Is it violating some sort of rate limiting, et cetera, et cetera. And that will probably be stored either in a database or some other system or logs, right? Now, as Sam and Mark kind of give that information to Jim, he's entering classification levels, and he tells them, don't worry too much. I'll explain those in a minute. For now, just trust me on that, and we'll revisit those levels together. And he also enters a description on the data designations, so that there is an actual explanation of what that data piece is about. So it's all at this point entered in a document, right, that Jim is responsible for, and Sam and Mark can really focus on providing the information. The data classification, right, Jim explains, is something that has been defined for the entire company, right? So it's not per project. It's really at the company level. At some point, the security teams and maybe the legal teams and the executives got together and decided to go, in this example, with 4 levels of data classification. So this is just an example of what you could go with. And of course, every organization may want to have different levels and different definitions for these levels. It is good to use an even number of levels, because in this case we have 4. If we had 5, there is a strong tendency, that's a human thing, to pick the one in the middle. So if you have 5, you always pick the third one, right? Really the one that's in between. It's the neutral one. You never really have to make a decision. It's neutral. Whereas when you have 4, you always have to decide between the second and the third one. And you have to actually think about the classification and the implications of picking one or the other. So usually if it's public or secret, it's pretty clear cut, right? But internal and restricted is more blurry here. So let's talk about it for a second. A public level, everyone inside, outside the company, everyone in the world potentially has access to it, right? Secret is only the owner of that piece of information has access to it. Potentially that owner may want to give it to somebody else, right? So if it's a password on a document, you might want to share that password with another individual. That's up to you, but by default, you're the only one who has access to it. Internal, here in this case, is everyone inside the company. Now, if we had a company with 200,000 employees, maybe we would want to have something a little different here. Maybe when you have 200,000 employees, flagging something as internal isn't very different from making it public, because the risk of it leaking to the internet is pretty high. But that's kind of depends on your context here. Restricted will be a specific team, right? So in this case, the production version of the application will be hosted by an SRE team, and every member of the SRE team most likely will have access to the storage buckets, right? And will have the ability to access all of the user data. So that SRE team is a dedicated group that has access to restricted data, and everyone within that group has access to that data, right? Similarly, a legal team may have every member of the legal team may have access to contract data, right? So you flag that data piece as restricted, knowing that a dedicated team will have access to it. And having these levels, even if they're not super fine-grained, I think they don't need to be super fine-grained, but they allow us to think about security controls around data, right? So, for example, going back to the previous table, the user data that's uploaded by end users will be flagged as restricted, so we know that the SRE team globally has access to it, but nobody else. The password is secret, so only the user has access to it, potentially they share it. But then the user account data, the data ID, the data telemetry potentially are internal, right? It's very common, particularly in smaller organizations, to have internal metrics on usage that are anonymized and are accessible to everyone in the company. So those are examples of data classification. It doesn't need to be exactly like this in your organization. The point is you need to do that work of defining it for yourself. So with this done, we have a good data dictionary, we have good context around it. We're now starting to focus on phase 3, which is really the meat of the threat modeling exercise, which is identifying threat scenarios. Now, the goal here is to identify how things could go wrong. It's a lot of fun for everyone, not just security people. It's a lot of fun for engineers because effectively you're asking them to break their own stuff. Now, in the RRA model, we frame it around the CIA triad, right? Confidentiality, integrity, and availability. Pretty standard for the industry. And for each area, we'll look into how an attacker would abuse or break into the service, and what impact that would have on the company's reputation, its finances, its ability to do business, its sustainability long-term, etc. We're also interested in like how likely is it to happen, but likelihood is tricky. So this is not a core focus of the exercise, right? We're a lot more interested on potential impact and threat vectors, really. How could something happen? Now here I want to take just a little bit of a pause and talk about someone that I really admire, Admiral Harper, who was one of the very first computer scientists that existed. She wrote the first compiler, and incredibly smart woman. And she used to tell the story of handing generals little nanoseconds, right? So 11.8 inches long pieces of cable to represent the length that light can traverse at the speed of light, and tell them like you go from point A to point B, and when you're communicating between 2 points you need a lot of nanoseconds. She was cheeky like that. And she also used to say that ships are safe in harbor, but that's not what ships are for, right? And this is a very important point when we're modeling threats and evaluating risks. Every business will take risks. It's not the job of the security team to prevent the business from taking risks. In the model of the RRA, the goal is to identify those risks, to evaluate them, to measure them properly, so that the business can make informed decisions. Now, it may be tempting to go into one of those exercises as a security expert and tell people that a given level of risk is unacceptable. And perhaps in some cases, it is true, and that's the case. But in the immense majority of cases, our job is really to inform product owners, developers, managers of the amount of risks they're taking and of the implications of taking those risks. And it's different from, those two mindsets are very different from each other. And I want to emphasize really that it is not our job necessarily to say no, right? But it's our job to make it so obvious that something is overly risky that everyone would agree not to do it, right? So with that said, here's an example of threat scenario. So obviously there will be more in an actual real world application, but here we have three. So for confidentiality, the obvious one is that an insecure storage would expose user data. Someone breaking into that storage could potentially leak all of that data. The impact will be high as the service is advertised as secure file sharing, and leaking that data could put users at risk, would break trust, would put the service in jeopardy, damage reputation, etc. Potentially the password feature mitigates that, but perhaps not sufficiently. We don't know password quality, etc., etc. So high risk. Integrity, this one is always interesting because few people outside security understand integrity, right? And here what we're really talking about is modifying the data that is provided to us by the user, potentially replacing it with something that could be harmful or damaging. An example here of that's fairly obvious would be to replace the files uploaded by users with ransomware. And then someone, the recipient of a file, would execute that file on their machine, install the ransomware, and be compromised, right? That would break the security guarantees to the user, would put them at risk potentially, could also potentially, if it happens to a large number of users, put the company at legal risk, right? So something that's interesting to flag. Now again, we're not lawyers, but we can flag this as something that the product team should probably go talk to the legal team about, right? And get an actual legal opinion on this, if they haven't done so already. Now, there are threat scenarios that can be even more twisted than this. For example, with a file sharing system like this, we could imagine replacing files with files that are illegal, right? And so that a recipient will download that file thinking it's a legitimate file. In fact, it's a file that puts them at risk of getting of essentially doing something completely unlawful. So the security guarantees around confidentiality and integrity are very, very important to the service, right? Availability here is probably a little less important. It's important too, but if the service is down, well, the service is down, you can't use it, right? You can't retrieve your files, you can't upload files. It doesn't necessarily put people at risk. It might break a little bit some terms of service, but not in a way that would put the organization at risk. So the risk level here, the impact level is medium. Now, obviously, we're putting impact levels here, but we haven't really defined them yet. And that's one question that Sam and Mark are immediately going to ask is, what are those levels? How do I know the difference between medium and high? And Jim would explain to them that impact scale has been defined like the data classification scale for the entire company. And this is actually something that is extremely interesting to do in your organization, is to work with the executives or their representatives in defining an impact scale. Because as security engineers, we tend to really underestimate the amount of risk that an organization is willing to take. And when we talk to executives, oftentimes we realize that they are willing to take a lot more risk than we think they're going to. Here's an example of an impact scale that is reasonable for a medium to large size software company. So a low risk would be losing less than $100,000, impacting less than 10,000 users, not really ending up in the media. A critical risk, one that could put the survival of the organization itself in jeopardy, will be losing more than 10 million, impacting more than 1 million users, and sustaining long-term reputational damage and potential legal risks. So if you think about the risks that realized in recent years, the Equifax leaking all of its social security number data in the US, that's a critical risk, right? Boeing, obviously, what happened to their 737 MAX, that's a critical risk. The Target leaked, I forget, 300 million credit card data. Would that be a critical risk? Probably not, because storing credit card data is not their business model, right? They ended up doing it because they sell things, but people didn't really mind. In fact, Target is doing just fine today. So what's interesting here is to define these levels with the right people in the organization. And once you have these levels defined, you can apply them to the assessments you do day to day. And doing it this way really allows you, puts perspective into a lot of the assessment work. In fact, a lot of these prototypes and experiments would end up being low to medium risk based on that scale, right? Because they don't have users, because they're not impacting the company's finances, and really no one cares until they reach critical mass. And a lot of the existing core functions of the organization will probably rank around high or critical, depending on how popular they are or how impactful they are. But it's very, very important to have even an imperfect impact scale for the organization. If you don't have one for your organization, make one up. Take the company's revenue from the past year, okay? A loss that's 20% of that is critical, right? And work it from the critical level down to low. And that gives you an idea. And you can start actually using that scale internally and maybe showing it to some of the folks. And ideally, if you can talk to your executives, good, show it to your executives and ask for their opinion and refine it this way, right? It doesn't need to be perfect the first time, but it will help you essentially guide security engineers and developers and product managers towards accepting the right amount of risk. Now, again, we tend to, as security engineer, underestimate the amount of risk an organization is willing to take. We will categorize something as high or critical risk when in fact it's probably low to medium risk. And I've done many assessments and reviewed many assessments where a junior assessor would put something as critical risk, and I would go back and say, this is probably medium. Let's go talk to the product team, and yes, they tell us it's medium, right? It's not that big of a deal. There are very few risks that can take a company down, right? In fact, throughout your entire organization, you probably should have 5 to 10 critical risks that you can't address. If you have more than that, it's either because you're taking a lot of risks, and maybe that's okay, maybe it's not, right? Maybe it's time to have a conversation with someone high up, or because your scale is wrong. And more often than not, your scale is wrong. So I highly recommend you spend some time refining this with the right people and get something tangible. With that, we get to a set of scenarios that are actually relevant to the product that Sam and Mark are building. So the next phase, phase 4, is to make recommendations. And this is what they came here for. Essentially, they wanted someone to give them their opinion on what they're building. And it took us that long to be able to give them recommendations. But it's also important to not give recommendations too early, right? You want to get the context, you want to get the data dictionary, you want to get the threat scenarios before you give the right recommendations. And I've done assessments where I didn't have recommendations. I looked at the assessment, I told them, your risk level is low enough, your design is clean enough, go ahead. I don't have anything that I think you should be doing right now. Once you have 10 million users, maybe come back and we'll do another pass, and maybe there are things we would want to do at that point. But oftentimes, the experiments, the prototypes that are low risk, they don't really need to do a whole lot of security work early on. In this case, though, given the confidentiality and the integrity risk, there's probably something we could do about that file encryption. So the business model doesn't require knowing the content of those files, thank God. And we actually would prefer not to have access to the content of those files. So one option would be to, for example, encrypt the file client side in the browser or in the application using AES GCM 256, and we can store that key in a URL anchor, because URL anchors are never sent to the server, and it will be used in JavaScript on the client side to encrypt and decrypt the file. Benefit of that is we get both the confidentiality, we know that it's a strong key and not a password set by the user that could be weak. So we know it's going to be a very strong key that's unbreakable. GCM is going to give us some integrity guarantees, so we know that if the file doesn't decrypt, then it doesn't even get given back to the user. They can't execute it, it just gets thrown away. There's no risk to replace it with something malicious. And it addresses both of these confidentiality and integrity risks in one go. So that's a good recommendation. We put it a priority level here, high level of priority. You should really do this, and you should really do it now, because it will define how the whole protocol works. And maybe there are other recommendations as well in this project, but maybe they will be of lower priorities, right? And can be done later or not done at all. And for Sam and Mark, that's the end of the meeting, right? It probably took them 1 hour to go through it entirely, and they feel pretty good about it. They got a good overview of their design, and they feel good about the recommendation they got. And they have this document that Jim has been fitting out as kind of reference point for future work they want to do around the security, so they can go out and build their thing. Jim's work here isn't quite done. It is done for this particular session of the RRA, but the bonus point here for security engineers is the risk register. So once you start doing RRAs, and I've done hundreds over the last decade, and my colleagues have done hundreds as well, you need a way to collect all of that data in one place, right? You have all of that great, accurate, interesting RA data. You have threat scenarios that are ranked by impact. You have recommendations. You have data dictionaries. You need ways to store that and manipulate it and use that to influence your security posture, right? Where are you going to invest? Where do you have the most risk, etc.? It is one point of your risk management program, and so you should put all of that data into a risk register. So my former colleague Jeff Briner loves making 3D risk register visualization tools. That's one of them here. You can use a spreadsheet, it's fine too, but the idea is you need to collect your RA data into a central place where you can really visualize how much risk your organization is taking in one place. And that's it for the overview of the RRA. You can find out more information at this link. This is the kind of official documentation, and we have some templates here as well. The Google Doc template, I believe, is available there as well. And if you want to know more, you're welcome to check out my book, Securing DevOps. There's a whole chapter on risk assessment there. And reach out to me on Twitter, the web, or by email, and I'm always happy to discuss these topics further. And thank you very much.